Qwiktix. Qwiktix is a centralized system that allows users to stream movies, buy movie tickets, review movies, explore different genres, and connect with the cinematic community all in one platform. The design of Qwiktix database and program was segmented to 3 stages. The first stage being the conceptual design, the second stage consisting of the logical design, and the last stage being the physical design. Now we'll move on to the first stage, the conceptual design of our Qwiktix program. Based upon the narrative created, we developed our Qwiktix ERD. First, we have users that can use the program. A user is identified by his or her user ID, and each has a unique email that he or she registers with. A user has a first and last name and address, a profile picture, and can have multiple phone numbers. A user can love as many movies as they want. A movie is identified by its distinct movie ID. A movie credits multiple people based upon their role in the movie. A person can partake in any number of movies, and they are represented by their person ID. Within Qwiktix, users can place orders on movies, whether they be a theater order or a stream order. Partnering theaters and streaming services fulfill the orders based upon their pricing and regulations. Partnering theaters have physical locations in which users can watch movies, and streaming services can be found at their respective URLs. Theaters and streaming services are vendors that are uniquely identified by their vendor IDs. This leads us into the next part of our design, the logical design, in which we talked about the relational schema. Now moving on to part 2, the logical design. The relational schema for Qwiktix was developed from the ERD. The schema follows all the design rules we went over in class. All entities have their own tables. Many-to-many relationships have their own tables as well, such as the credits table. In addition, multi-valued attributes have their own tables, such as character photo and phone number.
Provide our initial functionality. Using XAMPP setup from Apache Friends, we use this stack to create our database and provide a user-friendly web interface through the phpMyAdmin. MariaDB will serve as our relational database and provides the core of the Qwiktix system. Although not used directly in this project, Perl allows for further user extensibility and interaction with the database and web server. After configuring and starting the XAMPP Apache web server and MariaDB database, we used a browser window to navigate to the locally running instance of phpMyAdmin. This gives a graphical user interface to import our DDL, verify database structure, and execute queries directly through the database. In order to configure the structure of the database, we executed DDL queries to create each of our 15 tables, both adding primary keys and designating the unique attributes, and also defining constraints that link each table to one another. In this example SQL, we first create the user table, defining each attribute and data type. After, we designate the attribute user ID to be the primary key of this table and also require the email to be unique. Finally, we create constraints that reference attributes in both the movie table as well as the person table. After executing similar commands for all 15 tables, we are ready to populate the database with test data and perform sample queries. Using a free version of the web-based mock data creation tool, we generated test data. Though this material does not represent real-world data, it provides us with authentic-seeming data to confirm our database structure is valid, that all constraints are satisfied, that test queries return valid data, and that the database correctly represents the Qwiktix data as we intended. To populate our database with this test data, we created 50 randomly generated users. While not an issue for inserting users, in order to prevent errors when inserting tuples to a table that references a foreign key value that didn't yet exist, we disabled foreign key checks prior to importing and re-enabled them immediately after.
A user can do numerous things with the database. One thing they can do is request a number of reports or tasks. Each of these reports and tasks get useful info from the database that the user can then use for whatever they want. So one of the reports will select the movies that a user loves and then orders them by the profit that they made from all the different orders in the database, as well as the number of likes they got from other users. And the user requesting the report can set a minimum profit and number of likes to parameterize it and get selected data. And this report is useful for seeing what kind of movies a user likes, if they like a lot of popular movies or not, and can help just determine the different things they like in case, for recommending movies to a user. The second report will find the movies that sold the most tickets at a specified theater within a specific date. This query is very useful for finding out what movies are popular at certain theaters and also if they're popular within a certain time. So you can go back in time and figure out what movies were popular in different areas at different dates. This third report lists movies by the number of theater orders and stream orders and the difference between those orders and also their likes. And you can specify the genre and studio of the movies that you're searching for. And this report is very useful for seeing the difference of what kind of movies do well in theaters versus what kind of movies do well on streaming services, and if there's a difference between those movies and how much they're liked. This fourth report will list the people involved in movies and then order them by how profitable the movies they are involved were. And you can specify what role these people had in the movies, so you can get it for specific to see how popular an actor was in a specific genre of movies, and see who is the most profitable actor for drama movies. And this is useful to see how well people working in movies are doing and how well their movies do, and if you want to check up on a specific actor and see how well they're doing compared to other actors. This fifth report shows the movies in the genre that the user loves the most. So it finds the genre that user loves the most movies in, and then will select all the movies in that genre and order them by the number of loves that other users have liked the movies, and also by the movie's release date and order by the movie name. And this report is very useful for recommending movies to a user, because if they like a genre a lot, then they'll probably like other movies in that genre that other users love. And that is why this report will be very useful.
System architecture. For our relational database management system, we've selected MariaDB as distributed by XAMPP. The GUI that we use to administrate the database is PHPMyAdmin, which is also shipped with XAMPP. We use PHPMyAdmin to accomplish a variety of tasks, including initializing the database, importing our generated dataset, and setting security parameters for accessing the database. For building the application that interfaces with our database, we've selected Java 8. The application itself is a standalone client as an executable jar that accepts command line parameters and performs our reports and tasks accordingly. To universalize the build process for the application, we leverage the Gradle build tool. Gradle allows us to manage all dependencies for the application via a simple configuration file, provides a fast build process for initializing the application, as well as a headless build process for doing so without typical tools such as Eclipse or IntelliJ IDEs. For Java libraries, we leverage the core SQL library for preparing and performing the SQL queries, as well as parsing the return of those queries. Lastly, we will leverage the MariaDB Java Database Connection Driver as distributed by MariaDB, which plugs directly into the core SQL library's driver component. This allowed us to then use the core interface as we could for any other type of RDBMS backend. Now on to security. A common attack vector for database applications is SQL injection, where unsanitized user input can result in the execution of arbitrary SQL. The aforementioned Java SQL library supports prepared statements, which allows us to hardcode all associated SQL with placeholders for user input, and then set those parameters individually while sanitizing any potential SQL injections, as shown in the example here. In order to prevent arbitrary access to the backend database, we've protected it with security policies, all obtained via the PHPMyAdmin interface. For instance, we want to allow ourselves to be able to create and drop tables, but the application has no reason to perform these kinds of tasks. We do, however, still want to allow the application to query and modify rows in the database, and so that user only has the appropriate access. Once having established database security, access to application data such as user information needs to be protected as well. As such, we've implemented a login interface for users when interacting with the app, so that only the appropriate user can make changes to their own data. Instead of storing user-specified passwords as plain text in the database, we hash it upon initialization. Then when a user attempts to log in, they provide the original password and we hash it again, then compare the hash to what's present in the database. This grants us a simple and deterministic form of authentication without providing a potential hacker the plain text passwords provided by users.